Hi, I welcome you all for the session on steps in rapid prototyping. In our last class, we saw what are the basic steps in rapid prototyping. We saw in brief, but we'll see in detail. First step is create a CAD model of the design, later convert the CAD model to STL format, slice the STL file into thin cross-sectional layers, construct the model one layer upon it of another layer, clean and finish the model. These are the 5 steps in rapid prototyping. There are many processes in rapid prototyping, but these are the basic steps that is to be followed. First step is to create a CAD design model of the design. First, the object to be built is modeled using computer-aided design software packages. Like we'll use the CAD softwares, solid modelers such as ProE tend to represent 3D objects more accurately than wireframe modelers such as AutoCAD and will yield the better results. Using this ProE, CATIA, SolidWorks will give you better results when compared to modeling these are the modeling softwares. While compared to this wireframe software such as AutoCAD, the solid modelers softwares will give you more accurate results. The designer can also use the pre-existing CAD file model as he wishes to create the prototype. This is the sample CAD model that we can use. So we'll go for second step, converting the CAD model to STL format. There is number of different algorithms to represent these solid objects, but for establishing consistency for universal acceptance, stereolithography format is used. Hence, all the industries adopt this technique for converting. So, hence, we will convert the solid model into STL format. This format represents the three-dimensional surfaces of an assembly of planar triangles. It consists of many small planar triangular elements and it is assembled to form the particular STL format of a particular model. STL format consists of planar triangles. The file contains the coordinates of the vertices and the direction of the outward normal of each triangle, as STL file cannot store the curved surface. It can only store the plane surface. So plane surface will be easy for the storage, easy for storing and easy for converting to STL format. STL format cannot hold this curved surface, so curved surface is converted to planar surface. As the number of triangle increases, it increases the approximation, but the cost will be more and the file size will be bigger. As it is more complexity, it requires more time to build. Hence, a designer must balance the time as well as accuracy, and he should manage both accuracy as well as the time, because nowadays the time is the basic. Time is the most effective. Since the STL format is universal, the process is identical for all the rapid prototyping build techniques. The large files, as much we should avoid almost large files. This is one of the STL format. The red color you can see, that is the CAD model, and the black color triangular elements is for blue color triangular elements is for STL model. The CAD model, which is in the red color, is converted to triangular elements as you see in this drawing as STL model. Third step is to slice the STL file. In the third step, a preprocessor programming prepares the STL file to be built. There should be any interface between the solid CAD drawing as well as this machine building. That is stereolithography format. A STL file, as I said earlier, it contains a small triangular elements. So small element will be assembled to form a particular model. STL file approximates the shape of the part using triangular facets. Small facets produce high quality surface. Several programs are available, must allow user to adjust the size, location and orientation of the model. As I said that these small elements will produce more accuracy, but it takes more file size and it will take more time. Build orientation is very important for different reasons. First one is the properties of rapid prototyping varies from one coordinate direction to another. Properties, actually it has three-dimensional coordinate values, but in the Z direction it is less accurate and weaker. Hence, and other next condition, if we see that the part orientation partially determines the amount of time building the material. As we said that it is weaker in Z direction. Next one, we should take if we place the larger dimension in Z direction, it will take more time. Hence, we should place smaller layer in Z direction. The pre-processing, as I said, it is converting into a different slices number of layers. The layer thickness contains from 0.01 mm to 0.7 mm thickness, depending upon the build technique. The program may also generate an auxiliary structure to support the model during the build. Supporters are used for delicate features such as overhangings, internal cavities, and thin wall sections. Sometimes there should be need of some external holdings, or else you may not get the accurate model. Later, fourth step is construct the model one layer upon the top layer. The fourth step is the actual construction of the part. Using several techniques, RP machines build one layer at a time from polymers, paper, or powdered metal. Most machines are fairly autonomous, needing little human intervention. Clean and finish up the model. Final step involves removing the prototype from the machine and detaching any supports. As I said, if we give any supportings, we should remove that. Prototypes also require minor cleaning and surface treatment. At this stage, generally some manual operations are necessary. Therefore, skilled labor is required. Sometimes the surface of the model is finished by sanding, polishing, or painting for better surface finish or aesthetic appearance and durability. Prototype is finally tested later by suggested engineering changes or once again incorporated during the solid modeling stage. Later on, after building a prototype, they will test with the original CAD model. Then later they will make some improvements. Later they will develop a particular product. This is a generalized illustration flow of data flow in rapid prototyping. Finally, all the CAD drawings or any scanned any data should be converted to STL format. Because STL is universally accepted, I told that. 3D CAD model is directed to convert to STL format, or 2D they'll do like this, they'll convert from STL to later they'll give for machine data. So I thank you all for watching this video on steps on rapid prototyping. If you like this video, share and subscribe for our channel for more rapid prototyping videos. I am your Vijay who created this video. Thank you for watching.